Ignition sequence start. 5, 4, 3, 2, 1. Liftoff. We have a liftoff.
Good afternoon, ladies and gentlemen. Welcome to today's Schriever Spacepower series. I'm Jennifer Reeves, Senior Resident Fellow at the Mitchell Institute's Spacepower Advantage Center of Excellence. Since the dawn of the space age, remote sensing has been a cornerstone of national security. From the Corona reconnaissance satellites of the 1960s using film canisters to today's sophisticated digital multispectral sensors, the ability to observe and understand our planet from space has provided decision makers with unprecedented awareness of global events and warfighters a decisive advantage. Remote sensing encompasses far more than imagery. It also includes everything from detecting and tracking missile launches to monitoring weather and the EM spectrum. As we face increasingly sophisticated peer threats, the importance of resilient, persistent space sensing has never been greater. Leading this critical mission is Brigadier General Select Robert Davis, the Program Executive Officer of the Space Sensing Directorate at Space Systems Command. In this role, Colonel Davis leads the Space Force Directorate responsible for a $23 billion portfolio of persistent space sensing capabilities. Colonel Davis, thanks for taking the time to be here today. Let me turn it over to you for some opening perspectives.
Well, thanks, Boots, for that warm introduction, and thanks to the FAA Mitchell Institute for holding this important discussion. Super excited to be here today and share a little bit about what the men and women of Space Sensing Directorate out at SSC are working on. As you mentioned, there's a growing importance on space sensing and the capabilities that we bring to the fight, but it's not new, as you mentioned, right? It's something that's been around since really the first applications of space to the military domain, right? Missile warning, weather, and so on and so forth. So there's a long heritage out in LA and the people that came before us in this mission area. The ultimate high ground really does hold true here. Space sensing, has that long heritage. We'll talk more about that a little bit later, of delivering this capability for the nation. We have an amazing group of guardians, military, civilian, FRDC with Aerospace Corporation, other FRDCs, our civilian contractor, support contractor counterparts, all coming to the office every day to get after the mission of sensing, making sense of that data we sense, and then finally winning. That's our mission, sense, make sense, win, and it holds true. So super excited to share more with you and the audience today about what the men and women of space sensing are doing for the nation. Okay,
well that's great. We're so glad to have you. And gosh, we're going to talk about a few things, then we're going to go for some Q&A a little bit towards the end. But in the meantime, obviously this mission, right, we've talked about, or we're going to talk about a little bit about missile warning, missile track, a little EM, a little tech SRT is obviously vital to our nation's defense. So let's talk about that legacy. Can you share a little bit of the legacy of space sensing and how does that heritage connect to today's team?
Yeah, of course. So as I mentioned, right, going back into the 60s and 50s, that has the roots of what this SSC Space Sensing Directorate is today. But really in the LA South Bay there, it goes even deeper. There's deeper ties in that to defend the homeland. So every morning I wake up in a house that was built in 1917 to house the officers of Fort MacArthur that overlooks the port there in LA and Long Beach, obviously a very vital infrastructure area back today and back then for the nation. And Fort MacArthur was built in that early teens, 19 teens there to protect that port, right? So right there where I live, we are already protecting the homeland with the port, with the coastal defense artillery that you see around the nation's coastal regions. That happened throughout the war, World War II. And thankfully, nobody ever attacked the port, but just up the road in Santa Barbara County in 1942, and February 23rd, 1942, there was a Japanese submarine that surfaced and shelled some oil storage facilities in Santa Barbara County. So the threat was real. Then the nation responded, built Fort MacArthur, had that coastal defense artillery sites there up and down the coast, and protected that port. But then the threat changed. After the war, Cold War started, now the threat into the 50s was bombers, Soviet bombers. So what did the men and women and their families that lived at Fort MacArthur do? They changed. And they adapted, the nation adapted. We built, surface-to-air missiles, Nike sites, in the case of LA that formed a ring around Los Angeles and the basin there. And Fort MacArthur was a central place for that. Where I live today was a central place for that.
No kidding.
And those men and women protected the LA region. But then, the bomber threat became the ICBM threat. And then General Schriever and folks moved to LA and staffed the organizations that eventually became SSC to develop the nation's capabilities to have that deterrence against the ICBM threat, right? Then what happened again? The threat changed, right? Cold War ended, we won the Cold War. Now into the 90s and 2000s, we get to global war on terrorism. The men and women there that now are living at Fort MacArthur for, in the Air Force, supporting, LA Air Force Base there, are supporting more of a tactical, with regional conflicts, learning how to use these strategic assets in tactical ways, learning how to use DSP satellites, which I know you're fond of, to detect Scud launches in the deserts of Iraq, right? So how do we adapt to the threat of the day? And that's what the men and women that lived at Fort MacArthur in the same house I live into and their families, what they did then. Well, guess what? Threat changed again, right? Yeah. Here we are today with Russia and China, and we have to adapt. So I wake up every day in this house that was built over 100 years ago, that countless officers and families have lived in since then, with the sole purpose of first defending the port, the whole LA area, and then the nation, the homeland. And so that's what I wake up to every day. That's what gets me motivated when I wake up. And not everybody, obviously, that works in the space sensing team lives in Fort MacArthur, but obviously that same spirit is still there. We all wake up every day really, focused, hyper-focused on coming in and doing what we can to protect the homeland.
Well, I love that. I mean, that's very encouraging and very, I have like an upwelling of wanting to participate my own self. I mean, that's really lovely. So, but I think we're going to start to dive into some details, okay? So let's talk about a little more of the here and now. And let's talk about how we do things, how you guys do things there. We know the Space Development Agency has made a name for itself with its focus on rapid spiral development. But I understand your office is also actively implementing that approach with its series of EPIC, Missile Warning, Missile Track, MEO satellites. So can you lay out for us what the status of the EPIC constellation is and how your office is harnessing this spiral development model to build out the constellation?
Sure. SDA came on as a disruptor and really showed how a significant change in acquisition strategy, leveraging emerging commercial space can really have us do things differently. And SSC, not just in space sensing, but other elements of SSC have also adopted that approach to how do we incrementally field capability. Historically, we've tried to, take this requirement set and, one big monolithic architecture with one contractor go and deliver the capability. But as you mentioned, it's kind of changed now, right? We're breaking that apart into pieces, and we'll talk more about ground and space later in the conversation. But in this context of the space segment and SDA tranches, MEO epics, how do we incrementally deliver those capabilities over time versus trying to take a big swing for the fences every time and taking a while to get there, right? Particularly in this case, we have a very robust missile warning architecture today that's shown that the nation can defend itself, can help our allies defend themselves. That's absolutely working today. What we don't have is an architecture that's responsive to the emerging threats. And so this first set of tranches and epics are hyper-focused, pun intended, hyper-focused on those hypersonic targets and other dim targets that are out there that are really more challenging to the current architecture. And as we field those capabilities, we'll continue to incrementally deliver using this novel new approach the SDA kind of piloted for us and finish out the rest of the requirement set. So by design, it's incrementally moving in that direction, not waiting to be able to field a system that is holistically meeting everything it wants, getting to the capability we need today, continuing to grow the technology necessary to field the whole architecture. So really the same model that SDA is doing, MEO is doing here at SSC Space Sensing, others at SSC and other organizations are doing the same. One of the great features about it is between Space Development Agency and us, about every year or so, we are competing a new tranche, a new epic. And so it's really broadening the industrial base. And we're seeing a huge response from industrial base. Every time there's a call for proposals and a source selection for a tranche or for an epic, we're seeing that response coming from the industrial base. So that's very exciting as we are able to pull in non-traditional players in this area that drives innovation and whatnot. So that's great. Epic 1, he was awarded a couple years back. It's on track for its FY27, kind of mid to early to mid FY27 launch. The second launch for Epic 1 will be about a year later. We had to delay that one a little bit when we had a change in a contract approach there. That's one of the benefits actually of this strategy is having multiple vendors. If for whatever reason, if a contractor is having trouble delivering, it gives you options to be able to pivot to the contractor or contractors that are performing and to best use those resources for the nation on those contractors that are delivering. Historically, with previous acquisition strategies, you pick somebody and you were with them, right? Mm-hmm. And sometimes for decades, right? And so this rapid, frequent competition, multiple providers, gives you more flexibility there as you implement the strategy. So that's Epic 1 space segments going there. On our ground side for MEO, we recently opened doors and cut the ceremonial ribbon on our operations facility in Boulder at our Boulder Ground Innovation Facility, out there. And so we're ready to start integrating the ground systems for MEO into that facility and start doing the testing activities as we head up to launch and get all the readiness there. So that's exciting. And then just last month in May, we were able to award Epic 2, vendor 1 of Epic 2. So we're excited about that and starting with BAE there. We are postured to award to a second vendor late this fiscal year, early next fiscal year, depending on budgets. So we're excited about using the flexibility that our contracting strategy brings to get the most out of the budget we're allocated and to be able to pivot, and award contracts in a more phased approach in that competitive environment.
Yeah, I feel like that's important, certainly based on some historical examples that it just took a really, really long time with these big contracts to get us from point A to point B, where we had operational assets on orbit that we could actually use. So this sounds great that we're moving in that direction. So now, what this also means, though, is that we are seeing a shift from our traditional sort of geo-based, really SBIRS architecture, and even before that, the DSP constellation, to a more distributed multi-orbit approach. So yeah, we want to hear all about that. So what are the operational and resilience advantages? I mean, I think they're there for sure. What do we gain by pursuing a multi-orbit phenomenology for missile warning?
Sure, there's really two reasons to pivot away from the high altitude GEO-HEO architecture down to the low Earth orbit and medium Earth orbit LEO-MEO architecture. Mm-hmm. And they're driven by threat. Going back to my opening remarks, right? Everything we're doing is driven by the threat. So the first is the obvious one, the target threat. The things we're supposed to see and be able to track and pass to our users are becoming more difficult from the altitudes we traditionally have operated from. And so, not getting too into the physics, right? The closer you are to that energy source that we're trying to detect, the easier it is to see that energy source, right? It quickly falls off by the square, right?
The inverse square law.
Exactly, the inverse square law, right? And so you can quickly close on that by going to LEO and even MEO versus a GEO or a HEO altitude.
Sure.
So that's thing one. How do we see those dimmer targets? The folks that might want to hold our nation, our allies and partners, our troops downrange at risk, have seen how successful we are at traditional missile technology defeat. There's no better proof of that than what's happened multiple times now in the Middle East in the last year and a half, or even what's happening for a little bit longer in Ukraine. And so they've adapted, right? As you'd expect they would. The enemy gets a vote. And so they are fielding technology, hypersonics and maneuvering vehicles, so on and so forth, to make it harder for us to defend against those threats. And so we have to get closer to those targets in LEO-MEO, hypersonic maneuvering vehicles and other things that are maneuvering, to be able to still enable our teams to go and defend against those assets. So that's thing one, the threat. The other one is that, which is new in the last decade or so, is the counterspace threat. Well, relatively new. There's always a nascent counterspace threat in this domain and in this mission area. And we had jamming threats. We protect against that in our comm links. There was nuclear threats on orbit. We protected against those and hardened and all that kind of stuff that you're familiar with. Now there's a even more emerging counterspace threat, which you're well aware of and the audience is well aware of. And so proliferation is one way to counter that threat. And not just proliferation, but also disaggregating and dispersing your forces between LEO and MEO also helps you against that. And so now we have a robust, resilient architecture that meets my fundamental requirement to have that robust data architecture to provide our nation that unblinking eye for these missile threats. And the LEO and MEO architecture, by design, provide that resiliency. And the way the orbitology and stuff works, if somebody tries to counter either one of those architectures, either layers in the architecture, by creating a hole, the orbitology quickly makes that hole very difficult to exploit.
Sure.
And there's reasons between the two altitudes and characteristics of those orbits, which we can't get into here, but there's reasons those two parts of the architecture, based on the SWAC force design, the Space Warfighting Analysis Center, the force design they did a couple of years ago in this mission area, why those two altitudes exist. And so between Space Development Agency and SSC partnering together, we're fielding that architecture today for the nation.
Oh, that's awesome. Okay, so I've got a lot of questions.
Yeah.
So I'm gonna keep going. I think we may bounce around a little bit, but okay. So let's hit on, with this proliferated architecture, how are they all going to talk to each other? Okay. So the Epic 2 satellites will have vendor-specific crosslinks. Okay. With and you're planning even something bigger for Epic 3, right? We're talking about an inter-vendor meshing. And so let's talk more about these laser crosslinks, okay? Development, integration, interoperability. It's something that other entities, SDA, has struggled with recently. So now what are you guys doing to buy down this risk so that the Epic constellations are getting the most of what laser crosslinks have to offer, right? Super important.
Absolutely, and you kind of led right into it, right, with the beginning part of your question. In order to take advantage of these proliferated architectures, you have to have the comms, the communications are in the architecture to be able to close those links. And so to me, the crosslink technology, laser crosslink technology that we're developing and fielding is the linchpin of this new approach to proliferated LEO and MEO for missile warning, and frankly, for anything we want to do proliferation-wise at those altitudes. And so it's the closest thing that we're watching as a risk for the MEO program.
Well, can I stop you and ask you a basic question?
Yeah.
The basic question is why? Why can't we keep doing with RF inside the EM spectrum? Why do we have to go to laser?
Yeah, well, let's back up, right? Why do we need crosslinks at all?
Okay.
Right. So, as you and the educated audience knows, right? GEO's an awesome place to be from a simplicity of operations. You sit there, from the point on the Earth, and you're just staring. You can point your antenna. Nobody thinks about
Very
the fact
simple.
their
Yes.
DirecTV satellite antenna doesn't move, right? They come out, set it up, and it doesn't move, right? And GEO's awesome for that. Unfortunately, the same physics they allow for that make it a vulnerable place to be from a counter space threat, right? So thing one is you got to have comms. GEO made it very simple. We got to get out of GEO for counter space reasons, and also the missile threat. We got to get closer to the energy source, like I mentioned earlier. So now you got to change your comm architecture, and so we could build, hundreds or whatever the number is of ground antennas around the globe. That's impractical. It's also, creates other attack vectors, vulnerabilities in the architecture to have all those ground antennas proliferated around the globe. And so what has been shown is these crosslinks. And there's a history of having crosslinks in this area, like we were talking about beforehand, right? Early DSPs had the idea, AHF has crosslinks, Milstar had crosslinks, right? So the idea of crosslinks is not new. Your question about why optical versus RF, now you're getting to more technical trade space of the advantages and whatnot, and it really comes down to the ability of lower size, weight, and power applications, the optical crosslinks that are advantageous. And then as you get, increased data rates and ranges and stuff, you can have increased opportunities there too.
Right. So lots of data, essentially.
Yeah, lots of data, and you want those, at the range that we're talking about, right? The crosslinks, RF antenna crosslinks, again, it's GEO, so it's a little bit different, but you're talking, 6-foot diameter antennas hanging off of the side of these satellites, right? And if you're proliferating LEO, you've seen those satellites, I'm sure.
Yeah.
The whole satellite's not even 6 feet, right?
Right.
And obviously the crosslink distances will be different at LEO, so you wouldn't necessarily need a 6-foot satellite, but you can imagine having all the extra mass and complexity of those RF links would drive other challenges in design points and cost points, which creates problems with proliferation. And so people, not just the government in this mission area, but Starlink and others have quickly deduced the best technical solution, which has been proven by others, and then SDA proved it with government-led program could do it as too. They did in Tranche 0, which was by design supposed to prove some of these technologies as a pathfinder, not just for them, but also for SSC as well.
Sure.
Have proven that you could do crosslink optical crosslink technology in LEO.
Love it. That's great. So, okay, so let's keep talking about,
Crosslinks, yeah. So,
yes.
So you mentioned, Tranche Zero's, what they've learned. There's been some reporting on from GEO and others about, different interpretations of what they've learned and they haven't. I can say that like I mentioned a second ago, by design, they were pathfinding for the mission area and showing that you could do crosslinks, right? And we know the technology works. From my perspective, as I mentioned earlier, it's the closest risk we watch. And what we're seeing is the ability of other companies, other parts of the industrial base to mature their technology, mature their capabilities to be able to have that be more dependable and reliable. And industry is responding. So we're confident that we'll get there. To make sure that we're getting there, between the combined program office that we have with SDA and SSC and Missile Defense Agency as well as MDA, a lot of lessons learned have been shared there. And we are making investments in more ground testing, more test suites and whatnot to really wring out as much as we can on the optical crosslinks going forward for MEO and buying down that risk, right? To make sure we got an orbit that we minimize any discovery. There will be fine. We'll find stuff, right? We're going to be doing laser crosslinks in MEO, which we haven't, had a long history doing that at these data rates, these sizes, whatnot. So we're going to find challenges there, but we're going to burn down that risk as much as we can on the ground. And we're making those investments, those smart investments to burn down that risk. You mentioned about Epic 1 being vendor specific, and then as we move out through the architecture, by design, like I mentioned earlier, we're incrementally developing and meeting the requirement set. So to keep the complexity low and simple, to make sure we field that first Epic and even the second Epic to get after that hypersonic threat and not wait around for better to be the enemy good enough, we purposely made the choice not to push the envelope on the crosslinks with different standards and cross-vendor, cross-plane and whatnot. But that doesn't mean we don't need to get there. And so at SSC, between work that we're doing and work that's going on in other portfolios out there, we're investing in the maturation of other higher altitude standards. So in our partnership with SDA, we've been growing their standard to their 4.0 standard, which has protocols to account for the extended ranges that you get to from when you go to MEO with that standard. And we're also working with others to develop a SSC standard and mature that, which is purposely built for the higher altitudes and the ranges accompanying that. So we're investing in both those standards. We're a little bit of a horse race to see which one's going to mature in the industrial base, which one's going to be the best to put on contract for Epic 3. But our intent is Epic 3 that it will be a standard to allow that cross-vendor, cross-plane opportunities to close the comms, to increase that resiliency, and overall facilitate the architecture.
Oh, that sounds great. Yeah, that sounds really great. And then it feels like there's more opportunity to be involved, right? When we have a level of standardization. Okay, so let's go back to the threat and talk hypersonics. So the ability to track dim and maneuvering hypersonic missiles is truly next level for the nation, right? Big challenge here. And personally, as a missile warning guy, I feel that in my bones, right? If it's not burning, right, we're not seeing a big plume, how are we going to see it? So what are the biggest near and medium term technical and integration challenges that you are addressing when it comes to sensor design and data processing to ensure that we can detect and track these really advanced threats, and all the way from launch to intercept? It's a big question.
Yeah, there's a lot there. But people forget a little bit that the first time we launched a missile warning satellite as a nation, it went to LEO. So we obviously different era, different time, but we know how to do missile warning from LEO. We've done it before. Tranche Zero has shown that you can do it again. And so we have every confidence that we'll do the same in MEO. But the biggest thing I have is not on the spacecraft's ability to see it, but really it's a data volume challenge. We are going to, by an order of magnitude, increase the number of sensors, right? There's a dozen or so sensors today. But we're going to increase that by an order of magnitude when we realize these full architectures that are envisioned between the proliferated LEO and the proliferated MEO, different orbits, right? And not only are we, by order of magnitude, increasing the number of sensors, by roughly an order of magnitude, we're increasing the sensitivity of what they're going to see. So what are you going to do there when you have 2 order of magnitude increases on different parameters in the architecture? How are you going to handle all that data? So the first thing we're doing, especially early on, is the really pushing the onboard processing on the edge. And so again, another thing Tranche 0 has proven for their architecture going forward and for ours as well is the ability to generate two-dimensional tracks in orbit, right? Tracklets, whatever the case may be. And then do a lot of that front-end processing, if you will, to get that 2D track in orbit, which makes it a lot easier to pass, essentially it was a text message kind of data rates, right? To that messaging down to the ground to then do the final processing and ingestion to the 3D fusion engines to be able to get an actual, better missile track, right? Both for initial launch vectors and also the tracking and maneuvering that's going on. We know we can do that. And we've already shown with a wild field of view S&T asset we have on orbit today in GEO that we can generate that 2D track and ingest it into existing ground architectures, both on the Space Force, MDA, and other consumers of this data, and show that you can do that 2D track generation, right? And fuse that into the broader picture. So we're pathfinding with wild field of view as well. And then on top of that, we're doing modern sim to really understand, okay, with this volume of data we're getting down from all these satellites, all these 2D tracks, how are we going to make sure that our fusion engines to get that 3D track can keep up with that? And so we're practicing that as well with that modern sim. And really all this really comes down to the fact that ground is absolutely essential to this architecture. Ground's often an afterthought in space, right? Because we think about the nice, satellite, it's amazing, there's a launch, everybody cheers.
Satellites are sexy.
Yes, they are. But the ground is really, in this architecture, the key. And I've said repeatedly, it's just as important, if not more important, than the space segment is going forward in this architecture. And the central part of that for the Space Force is Forge. And Forge is not just a monolithic thing. It's a system of systems, and more importantly, it's a program of programs, which has really allowed us to take out, we've separated that big prime we talked about alluded to earlier, right? We've separated out the space and ground, and even inside the ground, we've separated out more into separate elements. So when I say program of programs, it allows us to individually compete those elements and pick the right vendor for that work. So instead of going to big prime, expect them to be really good at satellites, really good at ground, different pieces of the ground, be it software, be it antennas, whatever, and doing all that integration. We were able to select the best company to do that piece of the architecture. That's really, especially on software side, allowed us to go and get new non-traditional vendors that are really good at software, help us in the architecture.
Specialists.
Yeah. And so that puts more onus on the government to be a manager of that program of programs and that system integrator. But we're seeing tremendous benefits in our ability to feel the ground system in that fashion. And not only are we chunking it out, just like we are on the space side, we're putting time durations in these efforts. So in the Forge framework, for example, which in my simple brain's like the computer and the operating system, right, is the framework that you put the applications on top of. We had a vendor that delivered the first part of it, and then we were able to recompete that, and we were able to select a second follow-on vendor we felt like would do a better job in the next phase of the program, right? We weren't stuck or wed to a certain vendor for a duration of decades of a program. Allowed us to continue to be flexible there, make sure we have the right people doing the right work, and in the interests of the warfighter, in the interest of the taxpayer, making sure we're delivering on our commitments for the nation.
I love it. So how does, I have to imagine that AI and some kind of automation is playing into all of it, right? I mean, you illustrated quite well that there are going to be massive amounts of data, both on board and likely what's coming down, right? And we're building the comms in to be able to have all of that. So how are we incorporating AI, machine learning, those types of technologies into both the segments, the space segment and the ground segment, just for all the right purposes, right? We want to have increased effectiveness. We want to have reduced load on the operator, all the things. How are we using these new technologies?
Yeah, so we have a big data problem, and it's a good problem to have. I'd much rather have too much data than not enough data. But to your right, how do we take advantage of that data? How do we make sure we don't overwhelm the operators and so on? And so, I'm a simple guy, so I break it down in simple terms, right? Crawl, walk, run, sprint.
Okay.
So today at the OPAR Ground Tools Application and Processes TAP Lab in Boulder, Colorado, which I'm sure you've been to in your day.
Yes, I have.
They are leaning in hard on the latest data processing technologies, AI, ML, and whatnot. to figure out how to leverage those tools against our big data problem. And so that crawl phase, we were actively working with them, industry, and our brothers and sisters in arms at MB4, Mission Delta 4, 2 Swiss, 11 Swiss, to figure out what's the best way to augment, not automate, augment the missile warning operators when they have challenges with throughput and whatever the case may be. And we're seeing tremendous opportunity there in just a short period of time that the TAP Lab has really been leaning into this. And we're very excited about the early work there and working with Mission Delta 4 and the leadership team there to figure out, okay, how do we make sure we develop this in a way hand in hand with the operators so we can get right to the floor. There's an understanding and confidence of the capability of the machine, right? That sometimes in this mission area, rightly so, we want to make sure we understand that. And how do we get that into operations to augment the operator as quickly as possible? So that's crawl. How do we augment the missile warning operator? Then there's the walk. How do I do that same thinking on the battle space awareness side? So a lot of opportunity there. You might probably get a little more into automation on battle space awareness side because just the nature of the business there allows you to do that.
A little more time.
A little more time, and just the consequences of potentially getting it wrong are different if you're supporting a battle space awareness mission versus a street missile warning mission.
Yeah.
So opportunity for us to grow into more automation there as we develop the technology and apply the technology to our mission area. So that's walk. Then we get into the run phase. As I mentioned earlier, got a big data problem. I'm making numbers up a little bit here, but just for sake of discussion, I hypothesize we're throwing about 90% of our data on the floor every day. Right, we're seeing tons of stuff, right? You know what we can see. It's amazing capabilities. We're only going to be able to see more in the future. I mentioned with the higher sensitivity. So how do we leverage that big data problem? How do we go deeper into that data, pull out other battle space awareness features to support the operator? Then there's the sprint phase. How do I take that extra battle space awareness data I have? And how do I automate that machine to machine to support kill chains or whatever the case may be? And there's a gazillion different things you can think of there to apply that to. So that's very exciting as well. There's really that crawl, walk, run, sprint phase kind of thinking. How do I get after the emerging challenge of augmenting the operators in the environments we're seeing today? How do I apply that to battle space awareness? How do I dive deeper in that data? And then how do I apply that data, machine to machine, whatnot, to be able to apply in real time to warfighter problems?
Yeah, I think that's a great way to think about it, honestly. Because, and I can tell you, you and I have talked about things like this. An old missile warning guy sitting right here, and man, a decade ago, at least a decade ago, maybe even more, we didn't have customers and uses for all the things that we were seeing. So hopefully these new technologies will help us pick that up and find good utility for it. I'm super excited. Okay, so listen, I could sit here and talk with you about missile warning the whole hour, but we've got to move on and talk about some other things. And so let's talk about the future and looking beyond our current programs, what emerging technologies, and again, we've talked a little bit about each of these, but other things, whether they're in sensors and processing, other communications. What are you most excited about for enhancing our space sensing capabilities in the 2030s and beyond?
Yeah, the obvious place people usually go is that space sensor, right?
Yes.
And again, that's important, but to me, the ground is more important. Or I should say, the processing, the make sensing side is more important, because it might not always be on the ground. So my point, the first thing really is, how do I further enhance my ability to do processing on the edge? We're doing two-dimensional track processing on the edge today on the spacecraft with Tranche 0. We're going to be doing that in Tranche 1 and Epic 1. How do I keep expanding that thinking to 3D track generation orbit? I think the compute's there, now it's a comm problem and some other technical integration challenges, right? But how do I do that 3D fusion on orbit? If I get 3D fusion on orbit, what does that allow me to do? How do I get low latency comms to a shooter or to a weapon itself that's in flight, right? So you can imagine the possibilities there. And others are thinking about that, space development agencies think about it, we're thinking about it in the longer term architecture. There's also advantages of resiliency. If I'm on the edge doing 3D fusion, I'm less dependent on the ground, right? And I can get around the globe with my mesh network. And there's inherent resiliency in the overall architecture, not just the space architecture, overall architecture, if the ground segment and the link segment becomes under attack, right?
Yeah.
That's the basic missile warning, missile tracking mission. How about battle space awareness, though? Right now, not only am I going to be throwing a bunch of data on the floor or on the ground, I'm going to be throwing it away on the edge as well when I start doing that initial 2D track generation on orbit. because I'm throwing away all the other stuff that looks like it's in the noise to that 2D track. How do I get that data down? How do I get that wideband data down that we get today that then we can further refine and process on the ground to support battlespace awareness? So now I need bigger comm pipes because it's a comm problem. So how do I further advance the crosslink technology to get that data down? And now I've got a much bigger data problem than I have today because I've got a huge number of sensors that are all very much more sensitive than they are today. I got to process all that. So further AI, ML, whatever the next generation of advanced data algorithms are going to be, how do we keep leveraging that? And last but not least, I don't want to say the space sensor is not important. So how do we continue to leverage advances in commercial technology and whatnot that's pushing the sensitivity of those sensors higher and higher every day, right? What you can do today with your cell phone in dark places is just phenomenal to think about 10 years ago where you could take a picture. So focal point technology is maturing. How do I take those to space and see even dimmer targets, higher resolutions and whatnot to enable the mission? So that's what I'm thinking about in my head about the future of the mission area and what technologies, how we advance those.
I love it. Well, and I remember seeing new technologies with what DSP could already do, back when it was designed in the 60s and launched in the early 70s was unbelievable. And that sensor evolved over time. And then, my gosh, when SBIRS was launched, it was mind-blowing. Even the designer and the engineers were surprised at what was coming down from space once they finally got on orbit. It was amazing. So I'm thrilled to hear what's going to come next. But I have a suspicion we're not truly going to know until we have new assets on orbit and we see what's coming down. That's very exciting stuff. How about if we switch gears a little more this time and talk about weather? So DMSP, they are coming to an end, right? 2026, end of life. And so we've got a couple of new weather programs, environmental monitoring programs, EWS and WSFM, and they're critical to maintaining weather support to warfighters. So let's learn a little bit more about them, how these capabilities build on DMSP. The key thing is our warfighters need to have a clear environmental monitoring advantage, and how are we getting after that?
Absolutely. I'm glad we are able to talk about this. We spent a good chunk of our time already talking about a very important mission, missile warning, and it's a good chunk of my time and my team's time. But we can't forget the importance of our environmental monitoring mission either in the portfolio. I think people take it for granted a lot of times, right? Mm-hmm. Personally, we take it for granted. I think the warfighter takes it for granted. And, very important aspect of mission planning in all domains to understand the weather. You talked about DMSP. Huge capability for the nation for decades now. But as you mentioned, it's coming to an end, and we've deliberately decided to change how we deliver this capability for the nation. Instead of having a monolithic architecture, one satellite that has all the sensors to it, which create a very complex satellite, we've bifurcated that essentially into two. Weather system follow-on microwave, WSFM, and EO/IR weather system, EWS. And as the names imply, right, the microwave and associated capabilities with that are the one system, and then EO/IR and the associated capabilities there on the other one. So first we had the microwave capability, which really is designed primarily to help support the wind speed and direction, ocean surface. You can imagine the Navy cares a lot about that. And it helps other, hurricane forecasts and things like that too for the nation and for the world. And helping make sure we're delivering that capability. There's other capabilities that it brings to soil moisture content and ice thickness and things like that you get from that technology. We launched the first WSFM in April of last year. Checkout went swimmingly. It's delivering operational data today, and it's a great asset for the nation. Very proud of the team there. And we're going to deliver the second one in late 2026. And that'll be the completion of the current planned completion WSFM satellites. Pivoting to the EOR space, which is designed primarily to help support cloud characterization and theater weather imagery and a couple other things. We have the EWS system there, and it's going to be launching in late 2026 for the first one, and then the other one a couple years later. And then we'll have 2 satellites in orbit providing that overarching capability that DMSP provides today. But the question really is, what then, right? So both these systems were designed to think about how we do EM differently in the Space Force, and we've shown you can do that in disaggregation. The question is, do we continue that kind of architecture, or are there other opportunities? So first and foremost, a little known fact, but a huge percentage of our data we provide the warfighter today doesn't even come from DoD assets. We call it the family of systems, and it's comprised of other U.S. civil systems and a lot of international capabilities that the nations of the world have come together and fielded over the decades and share that data for the good of everybody on the planet. So a lot of that is already provided there, but how do we continue to smartly exploit that capability? But what about other capabilities that we can buy in the commercial space? So there's an emerging commercial capability set out there for weather, and so we're also looking at that as well.
That's awesome. Well, and of course leads into our next question.
Yeah.
We've got to talk about commercial.
Absolutely.
So increasingly, our commercial players are collecting remote sensing data, be it weather, like you're just talking about, electro-optical, or even signals intelligence. At the same time, though, I assume our purely military missions, more like missile warning, will remain a government function. So can you walk us through how your office is looking to implement the commercial space strategy that the Space Force rolled out a few months ago?
Yeah, well, SSE Space Sensing is really at the forefront of implementing that commercial space strategy. And even though the space strategy talks about things that, at least for the foreseeable future, will remain inherently governmental, like missile warning, and things that we can look to take more advantage of commercial capability, like environmental monitoring, I don't think it's a binary thing. Again, I'm a simple guy, so I'll break it down in my simple terms, right? I think it's a spectrum. Commercial is really on a spectrum. You have things like data as a service, where you go out, no kidding, you can go out today and buy a electrical optical picture of your house, right? Anybody can do that. That's pure commercial on one end of the spectrum. And obviously there's other applications there. We're doing that in tech SRT space, for example, using the commercial data analytics. You can go out and buy that commercial data analytics to answer a question to support a warfighter. So that's one end of the spectrum. Moving a little bit into that spectrum, right? There's commercial off the shelf. So I talked about Forge a little bit, and its program, system of systems. All of our developers are leveraging commercial best practices, commercial off-the-shelf technology for cyber, whatnot, to be able to support those capabilities. So that's leveraging commercial. Even though it's a government build project, it's still leveraging commercial. We'll take it a step farther. Take our MEO systems. We're leveraging commercial product line buses, we're leveraging commercial crosslinks and whatnot, even though that's a government build system. Oh, and by the way, we're also leveraging commercial operations there because it'll be government-owned, contractor-operated. So still commercial. And even the programs you might not think of taking advantage of commercial, I would argue still do on the spectrum, because we have a whole industrial base that is growing on the advent of all this commercial investment and capabilities. You have that rising tide that lifts all the boats. So even more traditional programs that you would not, like I said, connect to commercial capabilities are benefiting from the commercial market. So it's really that spectrum. And so I think it's really a matter of, okay, I've got a mission set, missile warning, environmental monitoring, whatever the case may be, across the DoD. Given that spectrum, how do I best posture that mission set in that spectrum of commercial capabilities? The balance, where the government needs to be more involved versus less involved, where you can take risk and trade that risk for advantageous from the innovation and cost points you get in commercial. So that's the first part, right? Let's talk about now more about the future of environmental monitoring. If I want to get away from government-owned, contractor-operated, leveraging commercial buses like I am today, building WSFM and EWS, and get more towards that pure data as a service, how do we do that? Well, I can't go down the street really today and buy dependable weather data from commercial services, right? There's no data as a service capability. Why? Because again, the nations of the world have been giving that data away for free for a long time, so the business case is a challenge. But there are a couple out there that are trying it. And there's a couple of, I'll say, similar technologies that we might be able to apply to get the same data we need. And so we're leaning hard on that in space sensing and the Space Force to figure out, okay, there's a nascent capability out there, or a few capabilities out there. How do I nurture that capability and try to grow that to the point where I can depend on it fully as a data as a service to really get the benefits you get out of commercial? So a lot to unpack there, and we don't have time necessarily to go through all that, but it's a tough challenge when you try to help figure out how to build a business case for it, because you don't want to end up at the point where you're essentially in a monopoly situation where there's only one data provider out there, because now that's not a good place for the government to be either. So how do you make sure you mindfully think about developing a market that really gets a pure commercial data as a service capability?
Yeah, but I also think that my takeaway from everything that you just said is that there's lots of opportunities And there are many different arrangements that we can make depending on the mission area that we're looking at, depending on what the objectives are, depending on what the threat is, et cetera, and what the industrial base looks like. So I feel sort of buoyed and encouraged that there's lots of opportunity out there on the commercial side for our industry partners.
There is.
Yeah.
It's just like I said earlier, just making sure you're not thinking about it monolithically, right? It's like
Right.
commercial or not, right? Even in government build, using split by build, monikers, right? Even inside build, you can smartly write your requirements in a way that leverages commercial. You can smartly, use COTS and so on and so forth, depending on the situation. Even in those situations where you don't feel completely comfortable because there's not a market there, or you don't want to outsource completely really vital capabilities for the nation.
That's awesome. Okay, well, great. Well, listen, man, this has just been going so well. The discussion has been fabulous, but I think it's time that we want to offer up a few minutes to our audience. So we're going to open the session to questions from the audience. And I think our audience tends to know the drill by now, and that is Josh is going to call on you. Please unmute your mic at that point, state your name and affiliation before you ask your question, or you can submit your questions using the Q&A function on the Zoom app, okay? And so with that, Josh, who do we have first?
Thanks, Jen. Our first question comes from Greg Hadley of AFA Magazine. Greg, unmute your mic, please.
Hi, can y'all hear me?
Got you loud and clear.
Awesome. Thanks, Colonel, or I guess I should say General Davis. Thanks for doing this.
Colonel Still.
My question, I wanted to go back to something you were saying earlier about the MEO missile warning architecture and the optical crosslinks. As we consider the progress of that program and the Epic 2 and everything you're planning there has been some concerns about the optical crosslinks, and you mentioned that as a big risk. How do you balance that risk as you move forward? You mentioned you're hoping to hand out more contracts for Epic 2 even later this year, perhaps.
Yeah, well, there's always risk, right? And so the key is making sure that we're mindful about how we address that risk. And so as I mentioned earlier, we, in partnership with Space Development Agency and Combined Program Office, we're really leaning into lessons learned out of Tranche 0 and investing more in our ground architecture to be able to do more testing and risk mitigation of that crosslink technology. So when we get to orbit, there's less opportunity for discovery. Not to say we won't have discovery in orbit, but we're better postured to respond to that. So we're confident that we're responding based on those lessons learned from Tranche 0, which again by design was the point of Tranche 0, right? To develop these lessons learned for both SDA and MEO to be able to take advantage of. So we're definitely doing that. On top of that, like you mentioned with Epic 2 and beyond a little bit, we're investing in standard development for the higher altitudes. SDA has a low altitude standard today that they are working with their vendors to field that technology to be able to do that cross-plane, cross-vendor integration, and we do the same at the higher altitudes. So in partnership with SDA, we're working on their SDA 4.0 standard, which has protocols for those higher altitudes, in addition to the SSC standard that also has, by design, the high altitude capabilities. So we're making investments in the architecture, not just from our portion of the architecture, but other portions of architecture on those standards, develop the crosslink technology, mature the industrial base for not just our mission area, but for all the mission areas that want to do proliferation or other reasons to use that technology.
Super. Okay. Thanks, Greg. Josh, who's next?
Our next question is from Frank Wolf. Frank, please unmute your mic.
Hi, I just wanted to, just on Epic 1, I believe Boeing Millennium was tracking to launch by the end of 2026. I wonder if that's still the schedule, if you're still tracking to that.
We're a bit later now. We're into 27. We've had some challenges on the design and maturation there, and a little bit in the supply chain. I'm still wringing through some things there. So right now we're projecting into second, third quarter of FY27.
Okay. Is there anything in terms of challenges that you can talk to in terms of what items, supply chain items, or what has specifically really has led to that sort of pushback? I think it's 12 in all, right? So they've got 6 and 27, and they got 6. I presume would be 28 or.
Yeah, so it was early 28 for that. We're not seeing the same shift in schedule yet for the Plane 2 of Epic 1. There's a number of items that are driving supply chain issues, number of items that are driving some of the technical challenges to make sure we get that right on the ground, make sure we do the right testing, the right rigor on the ground, so we get to orbit, we have a functional system to be able to deliver. So we're on track there, still pushing hard for that opportunity to launch in mid-27 there, and then be able to turn from that as the production line gets going on those satellites, build to print for that second plane into early 28.
Okay, thanks so much. All right, Josh, who's next?
Thanks, Jen. Our next question is from Vivian Machi from Aviation Week. She has a two-parter. First part, how many spacecraft are included in the anticipated second Epic contract? And the second part is, how are you currently looking at Epic 3 requirements? What will be similar to the first two contracts? What will be different in terms of capabilities or satellite numbers? And finally, when will solicitation start coming out for those contracts?
Yeah, so it's best to think about the number of satellites more than the number of planes. Depending on different design points that vendors offer, you get different results, the number of satellites. And I don't want to go too deep in that here, but if you have a body steered stair versus a focal plane that has a fast steering mirror and whatnot, depending on the optical design, you can get lots of different variations, number of satellites. So it's really about a plane of coverage. So we bought 2 planes of coverage in the first vendor, Epic 2. Time will tell about how many we buy in the second vendor. Certainly, obviously 1. We'll see if budget allows for a fourth plane as well, for a total of 2 in that second vendor's plane. As far as Epic 3 requirements, again, by design, we're buying as much and delivering as much as we can for the nation against that final requirement set incrementally as we go. And so just like we did with Epic 2, there'll be a long campaign of close collaboration with industry to make sure we understand what we can deliver in that approximately 42-month, 3.5-year timeline that we're focused on for capability deliveries for MEO Epics. And so we'll start doing conversations, industry days, draft RFPs and whatnot to get that final requirement set. I alluded to a couple times, you can expect a cross-link standard to be in Epic 3 to allow for that cross-vendor, cross-plane ability to communicate and provide more resiliency in the comm architecture. That's probably the biggest change you'll see. You'll see likely see increased requirements in battle space awareness as we continue to build out the architecture in a way that can replace the current architecture we have that provides those battle space awareness requirements. We have some nascent requirements in Epic 2, but you'll see a more fulsome set in Epic 3 more likely. And we'll look at other requirements in partnership with industry that makes sense to put in that requirements baseline. The last thing we want to do is get ourselves in a situation where we're asking too much, driving too much risk in that timeline, and now we're waiting around for capability to get on orbit. Like I said earlier, we're really focused on good enough, and we have opportunities every couple of years to get better, right? So that's the whole architectural approach and the acquisition strategy.
Wow, great. Okay, Josh, let's move on to the next one.
Our next question is also a written-in question. It's from Greg Lowe. He says, "Sir, congratulations on your promotion." And then the question is, what do you need industry and academia to focus on for your desired future capabilities?
Yeah, thanks. I kind of highlighted some of those opportunities earlier when we were talking about edge processing, making sure we have that really commercially sound base for our crosslinks, and we can be more consistent and predictable in our delivery of those systems and have more capability to bring more data down. I'm super excited about the possibility of getting that tremendous wideband data down we get from those more sensitive, much more sensitive by orders of magnitude sensitivity focal planes, closer to the Earth, closer to the energy sources, and you can only imagine what you could do with that data. If you get that data down to the ground, process it using modern processing algorithms, and what we can deliver to the warfighter there. So that's what I'm most excited about. First, making sure we don't lose sight of what we have to deliver today against capability the nation doesn't have today, but then with the eye toward the future as well, making sure we're getting that foundation built to allow more capability tomorrow.
That's awesome. Okay, let's go to the next one. Josh?
We have an anonymous question submitted to the chat. It asks, does the move to LEO from MEO mean we'll abandon GEO for missile warning, or will its broad field of view still be a part of the hybrid architecture?
Yeah, for the foreseeable future, we know how to build amazing satellites that last a long, long time, right? So for the foreseeable future, there will be a high altitude component in GEO and HEO, and we're committed to sustain that as we do the transitional architecture. But eventually, we will get out of GEO and LEO, out of HEO to the LEO-MEO architecture. Why? Again, because you can't see very easily those dimmer targets and the advanced threats from that altitude. And all the goodness that GEO has also makes it vulnerable to counter space threats. And so we need to get out of there from a threat perspective, both from a target threat perspective that we're trying to detect and track, and then from a counter space perspective as well, and pivot to that LEO-MEO architecture that addresses both of those threats.
Okay. Another one, Josh.
We have a lot of written in questions, so here's another one. This one is from Adam Curtis. He asks, are integrated mission deltas still being actively pursued by the Space Force? And if so, is SSC remote sensing participating?
Absolutely. We partnered with our Spock brothers and sisters at Mission Delta 4, right? Mission Delta being the key phrase there, and supported their stand-up last fall in October. We were instrumental in that coordination. There was an element of my portfolio that worked directly for me, still part of my portfolio, but they used to work directly for me, that sustained the SBIRS weapon system and associated capabilities at Mission Delta 4, or is now Mission Delta 4, and that we transferred over administratively to that Mission Delta to allow that Delta commander, Bobby Schmidt, for those who know him, to have unity command over readiness generation. Previously we had him have the ability to generate people, and I was generating the equipment. And so having that split, we worked really well together, our people worked really well together, and made it as seamless as possible, but obviously there was still a seam there. And so we moved that administratively and allowed the alignment of unity command for the Mission Delta to own all that readiness generation. Obviously a strong relationship there as we continue to work together on the sustainment and fielding of new capability.
Awesome. Okay, Josh, I think we have time for one more question.
Perfect. We have another question written in from Kylie Ho. They ask, what are your thoughts on leveraging space-based data centers to augment the edge processing done on actual sensing satellites?
Space-based data centers. Okay, that'd be interesting, having a bunch of online storage on the edge there. I don't think we've thought through that piece of it. I think we're thinking more of the real-time ability to process on the edge and then downlink the results of that, back through the current architecture, like I mentioned earlier, possibly straight to shooter, straight to weapon, to enable the more advanced kill chain work there. I'd have to think through what the advantages would be of having data centers on the edge and doing that processing on that stored data.
Well, that seems really interesting.
Yeah, it does seem interesting.
A very sort of different thought process to leave on. And so, and I think this is where we have to come to the end. Ladies and gentlemen, we've come to the end of this Schriever Spacepower series. Thank you again, Colonel Davis, for taking the time to speak with us today. As a reminder of our action-packed summer, don't forget to register for our next Schriever Spacepower series webinar, featuring Major General Tim Shaba and Chief Master Sergeant Carmen Monique Pogue, the command team of STARCOM, as they share the details on how STARCOM is shaping the education, training, doctrine, and testing vital to ensuring Guardians have the skills and equipment for warfighting in space in the 21st century. We will see you there next Thursday at 13:30 Eastern. So from all of us here at MI Space, have a great space power kind of day.